Welcome to AXA Arctic Live. We are in the northernmost permanent community in the world. Beyond us, not much else except for open expanse of Arctic Ocean, and then in 11 degrees north from us, the North Pole. We have a live investigation session today, microplastic sampling for microplastics, and we have a polar bear has eaten the internet cable here in the Arctic. That means just a trickle of audio, hopefully reaching schools, which we have in the UK, USA, Panama, Colombia, Canada, and Mexico. So it is a little bit of a tricky day today. We are fighting hard alongside the rest of the international research community here to get full comms back up as soon as possible. But it is not somewhere where you can just get someone in from outside to come and help. We are incredibly remote and pretty cut off here. We've had one helicopter come in to deliver a few scientists, but apart from that, we are in one of the more remote places on this planet. So we hope you can see a little bit of video. It will be frame by frame coming through, but hopefully the audio, which we're putting through a separate line, is reaching you loud and clear. So my powers of description will be pretty important for this call. We have had a great week up here in Ny-Ålesund, and that's on the island of Svalbard, and that is halfway between the top of Norway and the North Pole, if you can find that on a map. We have been doing a couple of things. We have been out in the fjord in a small boat, and we have been sampling. We have actually been sampling seawater, so we have been dodging icebergs, having frozen fingers at -25, having a surprise appearance from the largest animal ever to live on this planet, a blue whale. A pod of belugas swam past 50 of them this morning, the white whale, which was a great treat. But we have been looking at how the Arctic ecosystem is changing, and we've been looking at two things: how the chemistry is changing, and then how it is also having perhaps more plastic in it, and trying to work out, if we can, where that plastic might be coming from. So in our boat, we have been sampling in two main ways. We have been using something called a Niskin bottle, and if you can imagine, that is like a bit of drain pipe about a meter long, and it has ends on it which you can snap back with a piece of elastic. You then lower that to a particular depth, drop down a weight called a messenger on the wire, and that means the ends snap shut at a particular depth, and means we know what the chemistry and the plankton and the plastics are at that particular depth. We also use something called a Newton net, and that is like a very fine trawling net, and we tow that behind the boat and trying to collect samples. In fact, we have been on the edge of sampling with a Newton net, and we have managed to shred two in the very cold, heavy seas up here. So this is certainly getting data right on the edge of our ability to work, and that will be going into a long-term monitoring piece of work to study the changes in ocean chemistry and in looking at plankton and plastics. Today's session is looking at a science technique, sampling. So hopefully all of you have with you your mini ice flow, your set of ice with different bits of plastic set into it. Now, one of the problems of sampling is that we cannot get every single piece of plastic to work out how many pieces of plastic there are in the fjord. If it's big enough to hold a blue whale, it's too big for us to sample properly with just our couple of weeks up here. So we need to do what is called sampling. We go to specific sites along the fjord and think about how all of those together can make up a bigger picture of how the environment is changing, both in terms of chemistry, a process known as ocean acidification, which we looked at yesterday, and in terms of plankton and plastics. So I am going to do the experiment with you. So hopefully all of you have your trays of ice sprinkled with some kind of substance that you can see, and we are going to think about two things. We're going to think about how many samples we need to take to get a robust reading of it, and we're thinking about how we could then repeat that year on year to get a long-term picture of the environment. I'm just going to shift seats here. So we'll try and record this and get out a recording anyway. I have an apple corer. I have a lab tray full of snow and ice, and I'm using red peppercorns to represent my plastic. Now, I've counted the number of red peppercorns. They do have a habit of disintegrating somewhat in the water, but there are a number of things I can do. I can think about other science I know to develop my sampling plan, but actually what I think I'm going to do first off is just to do a line across the middle, a representative sample. So starting here, I'm going to take one coring sample, and there is more and more research out there looking at sea ice and the accumulation of, there we go, accumulation of plastics in the sea ice. Alright, let's take this one off here. And I'm coring along here, and I'm actually making a bit of a mess of things, if truth be told. Not quite down to a ripping mess, which I'm getting on the edge of sampling. But at the moment I'm coring along here, and although I have over 50, I won't tell you the exact number, pieces of peppercorn in here, I actually haven't found any so far. I'm just going to put my last core there, getting better at coring as we go along. Oh, there we go. The next core there. I wonder how you're getting on and how you're using your samples to estimate the total amount of plastics. This is a particularly hard sample, and so I'm just going to give it a bit of welly. I'm going to stand up and try and get into the ice here. I haven't done an ice core for a very long time. Last time I did an ice core was on one of the glaciers up behind here, and I can tell you, doing a sea ice core should be much easier than doing a glacier core. Sea ice, of course, has lots of tiny channels going through it. I need a spoon, really. I'll put my finger in there, see if we've got, still not finding any plastics. So sea ice is much easier to core because of the fact that when sea ice forms, it has tiny channels in it called brine channels, and those make it much easier to core than glacial ice, which is freshwater ice. There we go. On my last sample here, let's get the last bits out. I'm actually starting to find my plastic parcels, my peppercorns in here. Now, some of the background knowledge I may have learnt while I was doing my research to design my sampling is that peppercorns or plastics actually accumulate at the front of the iceberg, and that's down this side. So I've done a long sample along a transect here, this line, and I've seen that in fact, I can't find, there's a little bit left at the bottom of this ice hole. I can't find any plastics in here at all, but when I get to the end, I am finding some. So maybe it's better if I do a few more sample sites in each area of the ice flow. So I'm just going to, here, second one. Ooh, keep that careful. I'm finding there. So I've taken 1, 2, 3, 4, 5, 6, 7, 8 across, and I have found 1, 2, 3, 4, 5, 6, 7 samples, and that will give me an idea that there were probably about 7 and each sample I'm getting at the front here is yielding plenty of particles. Dr. Kerry Lewis will be coming with us. They're just trying to pack up some of the samples, and there have been some issues. So it's a day of issues up here in the Arctic, and we have just joked who would do remote field work or remote communications, where when things go wrong, there is very little backup for you. Make sure I'm not going through the side of this sampling case. We have a nice ice core there in the bottom of it here. There we go. So what we can see here, I've got two different sampling regimes. I've got one sampling regime that is going along the front of the ice floe, and what it is yielding is plenty of plastic samples in each core. And yet, if I took, so those are coming along the front of the ice floe here. We know that if you have the wave action coming here, have the wave action coming here, that's where the plastics will build up with the current and the seawater on the front of the ice floe. But as I sample back further, I've got another sampling technique, then it's trying to be uniform. So when I come back next year, I can come and test each of these places, and that's what we're doing with the sampling here. So along the top of the ice floe, lots, and then one going all the way back is very few. So that's just one of the ways in which we can look at sampling up here, and I'll come and sit down again. It is difficult, but two of the things you're looking at are whether it's robust or not. So, am I doing everything right? Am I making sure that I don't have plastics on my person, plastics coming from the air, that kind of thing? And is it repeatable? So, am I doing exactly the same thing year after year? And so, what we're doing here is that we are going to the same spots. We're using GPS. We can put those onto something like Google Earth and have a picture of where we've been sampling, and we can make sure we're coming with the same kit on the same boat and doing exactly the same thing year after year. And by doing that, we're making sure that our measurements can then become data and then used in scientific papers. So that's just a short, fun way of seeing some of the sort of tough ways of getting samples from the Arctic. If you have put in exactly the right amount of sort of lentils or peppercorns into your sample, and think about how many different samples you'll have to take to get a true reading of how many bits of plastic are in your sample. So hopefully you've had good fun doing that, and you've come up with some estimates. Maybe you've taken 20 samples, and that represents 10% of the area that you're sampling in total, and then that means you will have to multiply whatever you get by 10, so it's 10% to get a whole figure. So if you've got 20 pieces in your 20 samples, but that represents only 10% of the area, you can multiply that by 10 and that would give you some 200 pieces in there. So see how accurate you can get. The other thing to think about, of course, is that we don't have the resources to sample the whole of the Arctic, so we just need to take samples to give us a representative idea about what is happening up here. So it's great to have INEM in Columbia, Boulder Academy watching, Livingston High School and Union Point Academy, and also King's College, Panama. A couple of questions through from King's College, Panama. How do you sample microplastics and measure the quantity of them? That's a really good question. So for the sampling, we do two things, and I've mentioned them before. We have a surface tow, and so that's using the net and dragging the net through the surface of the water, and the plastics particles, if they are here, and we found some last year, accumulate in the end of the net, and we rinse those out into a bottle, store them, and then take them back for analysis. And the other one is using a Niskin bottle, which we put down to depth, and then we can pour that through the net as well, and then measure those. But that's knowing what's at specific depths, which is super important for understanding how plastics behave in the waters up here. And measuring the quantity of them is pretty complicated, so that we get that back to university, and we use a special machine that looks at the chemical composition of each of the particles we find. So that's a lot of microscope work, and making sure that what we think is plastic in the little fibers or particles is actually plastic. So we have to know what the chemical composition is, and then by hand under a microscope examining each particle very carefully. So we might find other particles, but it's very important that we don't include those in our plastic count, and they are very, very tiny wee, the plastic particles that we find here. So in order to establish whether there is a lot or a few plastics, or the number, quantity of plastics in the Arctic waters up here, we do two things. We do the sampling, and then we do the lab analysis, and then that combined gives us an indication of the amount of plastics in the fjord. The second question that I have from King's College, Panama, is how do you suggest we can get rid of microplastics? A lot of microplastics don't start off as microplastics. There is a current debate in the science community as to exactly what constitutes a microplastic. The current piece is that it's any piece of plastic which is smaller than 5 millimeters, but some people are suggesting that should be sort of 1 millimeter across. That's more than 1 millimeter. So what we're looking at is that a lot of that microplastic comes from larger pieces of plastic which have broken down, become brittle in the UV light, and broken down by wave action. They become these smaller particles. There are other sources of microplastics, such as washing polyester clothing, and fibers come off the washing and into the ocean, often through the drainage system. And then there are nurdles, which are the pellets used for plastic manufacturing, and often those can find their way into the sea as well, often through spills from ships. So there's most of the plastic that we're finding is broken down plastic from large items, rather than small pieces of plastic that have been created either as pellets or small pieces of plastics, often from cosmetics, but we're working on getting rid of microbeads in cosmetics. Stephen at Boulder would like to know how, we didn't really talk about how we can get rid of microplastics. I was describing what they are, which really covers Stephen at Boulder's question. In terms of getting rid of them, it's really cutting down on those sources. There are items that you can put in your washing machine that accumulate the fibers, so that's one way you can do it. I think, I don't know the exact name, but we can get that up on the live chat in just a wee while. You can cut down on your use of single-use plastic, and that's especially from the food and drink industries. So making sure that if you have access to safe drinking water, you do not need to buy a bottle of water. And looking at the plastic packaging on your food. So those are two areas to look down at that, and also carrier bags. So keeping your food in a box, even a plastic box, it's not single use, having a water bottle that you refill, and having a bag that you reuse. So those are some forms you can do. Definitely not using any cosmetic items or toothpaste that have plastic beads in them. Really cutting down on that. And also any other items of using virgin plastic. So that is sort of fresh plastic. Just if we're using less plastic, then less, fingers crossed, will get into the marine environment and break down into smaller particles. Here's a great question from INEM. What characterizes scientific thinking? I mean, I think what characterizes scientific thinking above and beyond other types of thinking is this idea of empiricism, of being able to measure something and come to conclusions based on what we measure. So you can have different theories about the world, but the scientific method is based on measuring often a smaller sample and coming to a conclusion based on that. So the scientific method is having a hypothesis, an idea about how the world works, going out and collecting data, so measuring to see whether you can support that hypothesis, and then writing up a conclusion to say, we thought this would happen, we went out and tested this, here are the figures, and this is what the result is, and therefore we can say that X, Y, Z. I think one of the big changes that is happening in scientific thinking at the moment is something called big data, where instead of having smaller samples, people are saying that we can have a sample where we have an idea about everything that's happening. So that is being enabled by some of the internet technologies that are happening. So scientific thinking I would put down to empiricism, hypothesis, testing, making sure that your testing is robust and repeatable, and then getting your data, drawing conclusions and sharing those. Erwin would like to know how dramatically you think the levels of microplastics will change year on year. Currently, the projections for plastic production are quite astonishing. They are a very steep upward curve. We have some of that information data back in the office. I don't have it to hand here in the Arctic. And if we do not manage that plastic properly, if we're not recycling it, and it is leaving a closed loop of being used properly and is mismanaged, then it will get into the environment. And so if there's more plastic, one might assume that a similar percentage of that will get into the environment, and that would mean more plastics in the environment year on year. So it's definitely something we need to take action on very, very rapidly. It really is surprising, with all the media attention focused on plastics, especially from what I've seen in the UK, that we still have a very steep projected increase in plastic production globally. From Union Point Academy, how many years has the team been sampling for microplastics? In terms of this Arctic program, this is the middle of a 3-year monitoring project, but we are joined by a team from the University of Exeter who have been sampling and working with plastics for, I think, certainly Kerry's been working on plastics for about 5 years now, and very experienced team looking at the plastics issue. So next from INEM, how can you measure the exact amount of microplastic? As mentioned before, that's not something we can do with the naked eye. That's something that has to be done back in the laboratory using the chemical signature of each particle. So working out, is this plastic, is it some other substance? And really from that amount, it is a laborious task. So it will take many months before we know the exact amount of plastics in our sample. Maybe one year we'll be able to automate that a bit better, but for the moment it is a single piece by single piece under a microscope and testing those. Um, Next up from INEM, are ecosystems in the Arctic the same as they are displayed in books and films? Wow, what a great question. So if we sort of widen that out to polar, and I'm just realizing my samples, when I'm answering that, my samples are melting into my desk here. So I'm just going to clear up quickly before that gets too messy. Clear up the samples from the desk before that. It is incredibly dry here, so hopefully that will all, I'll put that down on the ground. Whoosh. There we go. Sorry about that. We're just having a sort of slightly leaky ice flow on your desk as these things happen. So coming back to books and films about the polar regions, I think for me the best book I have ever read about the polar regions is Arctic Dreams by Barry Lopez, and I think he really captures the essence of the Arctic. The best film I have seen about working in the polar regions is Encounters at the End of the World. I think it's Encounters at the End of the World by Werner Herzog, the amazing filmmaker. And he was working, in fact, I think it was at McMurdo Station, which is down in Antarctica. But what you have is that mix of, there's tractors, there's a power station, there's sort of all this sort of activity going on, there's lots of people around in this very small space. But suddenly when you leave, you are surrounded by the great Arctic wilderness. So you're like 10-15 minutes by Skidoo out of here, and you are in the middle of the Arctic. You're half an hour on a boat out of here in the middle of the Arctic. It is quite amazing. So I think that Werner Herzog gets that balance really right. What it's not like is some of the nature documentaries where I know that they spend many weeks or months filming the wildlife and going off to wildlife. We do have some spontaneous moments of spotting wildlife out here, but the films that you see and the photographs you get in magazines are the result of a lot of patience. So it is not like living in a polar safari park, but you do get the odd glimpse, and those are incredibly special. I think even more special because they are the odd glimpse up here. But if you want to get an idea, I'd go for Arctic Dreams by Barry Lopez, and then for film, I would go for Encounters at the End of the World by Werner Herzog. So those are my two tips. Are ecosystems? That was that one I just done. From Zach, Eric, and Susan at Livingston High School. How do microplastics affect our marine and human life? It's a really great question. So in terms of microplastics affecting marine life, we call them microplastics because when they get to that size, we see that they are available for tiny wee creatures like plankton to eat. And so what we're seeing at the moment is that they're going into the plankton and they're eating them and then basically pooping them out. Now the questions out there are, if they are eating plastic, does that mean they're eating less algae and so they're getting smaller? That's an important thing to think about. And also, can they be passed on to other animals and get into the tissue there? That is a current area of research. So we know that it is very pervasive. We are trying to work out where the health angles are. So it is a pervasive marine litter. It is getting into animals. It is being pooped out. We're trying to work out, for instance, if inflammation might be an issue. So as plastic goes through the intestines of an animal, and it causes any rips or scarring, is that causing inflammation which can lead to further disorders? Do microplastics break down? And we know they do break down into even smaller plastic particles, nanoplastics, and can those pass through the gut membrane, so into the tissue, and can they take any chemicals bound to them into the tissue as well and cause further damage? So it's definitely something that is important to look at. Other areas are they taking diseases, for instance, to areas where they might not already be, or diseases piggybacking on microplastics? And people are thinking that, especially as a health hazard in natural disasters, so where you might get a lot of plastic waste, a lot of human waste mismanagement, and can they start to move these diseases very rapidly through the ocean? Very important areas of current research. Another question from INEM: what is the best way you have found to report your findings? That's a great question. And so the standard way of reporting scientific findings is through something called a peer review journal. And that is where you write up your research project into a set format, and then you send it to a journal, and they'll say, thank you very much. This suits our journal or doesn't suit our journal. And if they say, yes, this suits our journal, they will then send it to hopefully 2 other experts in the field who will look over what you've done and check it. They might send it back to you, say, yeah, we need a bit more information on this, or that doesn't seem quite right. Are you sure about that? And so you will have this check by people who are of a similar standard to you, your peers. And then after it's gone through that process, then it will be published. Then other scientists can refer to it in that set format. There are other ways that findings can be reported. So that research, having gone through the peer review process and being published in a scientific journal, can then be used to influence policy. Government departments are making policy based on evidence. And the second thing is that they can be used in outreach programs such as Arctic Live to resources we make to help you have access to cutting edge science in your classroom and help you to form your own ideas about the changing world and what you can do about it. INEM also asking, how frequently do you collect data to make conclusions? It really depends on what kind of work you're doing. So we are doing a time series piece up here. So we're looking at how these levels might change over time. We have funding to do the first three years from AXA XL. And so we are doing 2 weeks every year for 3 years. And that will start to give us an idea about change over time. If we can extend it, the more you can extend these time series, the more valuable they are to scientists. Because really what we're looking at is environmental change, and then looking at the causes and drivers of that change. We have from Justin, Casey, Malcolm and Lily at Livingston High School, what are some of the challenges you face studying microplastics, ice and climate change in the Arctic? So our study is on climate change's sort of twin effect, ocean acidification and plastics up here. Challenges: frostbite, frost nip, crashing into icebergs, losing sensation in fingers, the sampling equipment freezing shut, not getting our chemicals up to the Arctic in time, our flights being delayed through technical problems, nearly missing a charter flight over the mountains, the sea state being too rough, and nearly having things washed overboard, and dodging blue whales, and that's about it really. So not many challenges at all then, apart from the cold, the weather, the waves, the remoteness, And we shredded a couple of plankton nets because the oceans up here are heavy oceans because they're so cold at minus 1.8 degrees Celsius. So a fairly challenging place to work, but also a very important place to understand. Some results in from Boulder Academy, a range of results from 220 to several hundred. The actual total in each sample was 200. Roxy, Reese, and Ella were the closest. Roxy, Reese, and Ella, big thumbs up, and Arctic high five from the Arctic. Fab sampling by you guys. We've got another one on the challenges of collecting samples in the Arctic, and we've just gone through a few of those. For me, the one I hate most, you haven't had some things you go, oh my god, I think I'm going to die. That hasn't been on this trip. Having an iceberg very close to the boat I was saying ice quite a lot, repeatedly, as a warning, and there was nothing much we could do about it. It was quite far away. It was about 14 inches from the boat. Then other challenges to collecting samples in the Arctic. The cold, I think the more you come to cold places, the more your fingers go quite quickly, and your fingers go numb and you can't feel anything, and there's a bit of pain there, and then they sort of really go, and you just sort of get through it. It's the defrosting that is the absolute pain. And Nick, the station manager, came back in today, and we were running the cold tap to see if we can get it cold enough so that it wouldn't hurt his fingers too much as we defrosted those. Or defrosted is a sort of metaphorical term. It's not sort of getting fish fingers out of the freezer and making those getting those defrosted, but it is really trying to get the blood back into the end of your fingers, and it is incredibly painful when it comes back in. Audit from Boulder Academy would like to know if there is any difference in the data collected in summer compared to winter. Audit, that's a great question. We are not sampling in the winter here. It would be great to be able to do both, to sample both in the winter and the summer. I am afraid that we have taken the easy option, and we are only sampling in 24-hour daylight. Some of the problems that you would have in sampling here in the dark, in the winter, 24-hour darkness. If you did use lights for navigation, that would influence the behavior of the plankton, because they might think it's the moon and behave differently, and it's an artificial light you're introducing into the environment. Of course, the cold, so you're starting at minus 20, 25. We're starting about minus 5, minus 10 at the moment. Add wind chill to that, you're getting down to minus 35. Everything would freeze instantly. You got it out of the water, unless you could get it into the cabin quick enough. You'd be very painful and quite difficult. The deck would be frozen solid with frozen seawater, so it'd be pretty slippy. You might even have to wear crampons on the back of a deck of a boat, bobbing about in the Arctic. I would love to try the challenge. So if we ever got funding, it would be great to do a summer series and a winter series as well. So we don't know what the difference is because of the challenges of coming up here in the winter months. We are just here in the summer at the moment. Here we go. Is the research being done in the Arctic currently happening in other places to compare results? Dr. Kerry Lewis mentioned being in the Galapagos earlier. Yeah, I mean, getting an idea about plastics and how they behave and where they are and how they affect marine life is something that is a bit like a jigsaw puzzle. So that each of these different research projects happening around the world, Kerry was talking about a couple that she's involved in, and you're choosing your research site based on what your interest is. And those pieces of jigsaw then all come together and they start to form a bigger picture of marine plastics. Are any animals more vulnerable to the impacts of microplastics than others? Certainly when we're thinking about why we call it microplastic, is that it is available to plankton, so to the smaller creatures in the ocean, such as copepods, pteropods, amphipods and krill. So that means that bigger bits of plastic they can't eat. So certainly microplastics are more harmful there. Hannah from Boulder Academy would love to know what inspired you to go to the Arctic. I mean, I think if you get an opportunity to go to the Arctic, you grab it with both hands. It is simply a huge privilege to be somewhere so remote. The first time I went to the Arctic, which was 8 years ago now, it was a very remote area, somewhere that most people will never ever see, camping on the sea ice up in the high Canadian Arctic. And if you're a lover of the wild places, remoteness, the beauty of this planet, and it is fairly gnarly as well. So we had temperatures with wind chill down into the -60s, ambient temperatures down to -48. Most days were sort of around -35. A great group of people. The colours were amazing. We had the air freezing, and so it was like walking through a cloud of sort of diamond dust. It was sort of ripples of golds and pinks and blues, and with the sort of not quite setting sun. It's just a spectacularly beautiful place, and at the same time, it is undergoing rapid change. So twofold. The first time I came up here, it was just amazing to see it and to talk about its beauty, and now more and more talking about its fragility and how it is changing. So hopefully Arctic Live will give you some insight into this part of the world and the need to protect it for future generations. We've just got time, I think, for one more question. If you could be a sea creature, what would you be? I would be a Christmas tree worm because they're funny and they're very far away from here on the coral reef, but I love them. They look like miniature Christmas trees poking out from the coral, and you can cut them into 7 pieces, but no more, and each of those 7 pieces will regenerate into a Christmas tree worm, which I think is a truly astonishing regenerative feat. I don't think could be cut into 7 pieces and regenerate into 7 me's. I don't think people would want 7 me's on the planet. But there we go. Thank you so much for being part of AXA XL Arctic Live. We are back in just over an hour's time for an expert interview with Dr. Kerry Lewis. And if there are questions that you asked just now that you would like finer detail from one of the lead researchers in this area, please do post them again at the bottom of this live chat, and we will make sure that we save them and transfer them over to our Dr. Lewis exactly for more details on her research and the growing research on plastics in the marine environment. So it's a big Arctic goodbye from me. Until the next time, bye bye.